Okay, 912, and here we go. We're going to put some of those t-value things into practice here. I'll do 11. It says the owner of Britain's egg farm wants to estimate the mean number of eggs produced per chicken. A sample of 20 chickens shows they produced an average of 20 eggs per month with a standard deviation of 2 eggs per month. And that standard deviation is of our sample, not of the population. So I hope I've been saying that correctly along when we were talking about the t-values, but we use those when we don't know the population standard deviation. So in this case we just have the sample standard deviation. And so question A is first, what is the value of the population mean? What's the best estimate of this value? Well, our sample means 20, and that's the best estimate that we have, and so we got to say that it's that's probably the population mean too is 20, and it's because that's all we have, right? B is explain why we need to use the t-distribution. It's because we don't know the population standard deviation. We've got a sample standard deviation but not the population. That's the assumption that we make. And then C, it says for a 95% confidence interval, what's the value of t? Okay, two-tailed. Remember, it's this two-tailed test that we're still working on. We haven't gone to one-tailed test yet. So 95, then I come to here, or the 0.05. Okay, 20 was my sample size, right? So my degree of freedom then is what, 19. And so I'm at this column and this row, so 2.093 then is my t-value, okay? And so my formula is basically the same formula that we were using back here, except that, it's x plus or minus t times the standard deviation of the sample, okay, divided by the square root of n. So we do the the same formula. I don't know what all I did here. I think I took the standard deviation, divided by the square root of n, or s, my sample size, okay, equal to standard deviation divided by the, I think I think you can do this if you want. You can come and do math and go to square root. I think this works. Square root of this number. There you go. So you can do it that way. You can do it the other way too that I've showed you. And then that it's got to be multiplied by our t-value. I'm sorry, lost my train of thought there. So that gets multiplied by our t-value to give us this number, or this number. So equals this times our t-value. There we go. Okay, but then again, remember it's plus or minus, so it's x plus or minus this t, right? Times the standard deviation divided by square root of our n, and so our mean, or x, is 20. So again, we just simply go, that's equal to this one minus this, and this one's equal to this one plus this, or the other way around, of course. So then it asks us, it says, what would it be reasonable to conclude that the population mean is 21 eggs? What about 25 eggs? Well, 25 eggs would be completely out of range, right? And with 95% confidence level, 21 doesn't quite cut it either. It's pretty close, okay, but I'm gonna have to say no. If I had a higher confidence level, if I wanted to have a higher confidence level, say this is 99, my t-value would get bigger, right? okay, and this spread would be bigger, right? So I'd have more confidence that my population mean would lie in between those various numbers. But at this point, I'm going to say no, it's probably not reasonable for either one, even though it's really close there. Close doesn't necessarily cut it here.